Now, what do you do when you can't do MAC factoring? In this problem right here, 2 sine squared of x minus 2 sine of x minus 1, if I take the first number and multiply it by the back, 2 times negative 1 gives me a negative 2. What are the factors of negative 2 that add up to negative 2? And I'll say, there is nothing. And what did we do first semester when we ran into this situation? Well, if you recall, we used quadratic formula. So as a quick review, the quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. And when we run into the situation where we can't MAC factor with trigonometric equations, we're going to apply the quadratic formula, where a is my leading coefficient, b is the middle coefficient, and c is the back coefficient. The piece that's a little different, though, is instead of saying the quadratic formula is equal to x, we're going to say it's equal to the sine of x. So the sine of x is equal to that whole equation. And then when we simplify that down, we're going to take the arc sine. So starting off, let's plug everything into the quadratic formula. The sine of x is equal to the opposite of b, which is a negative 2, plus or minus the square root of b squared, negative 2 squared, minus 4 times a, which is 2, times c, which is negative 1, all over 2 times 2. And we'll go through and simplify that. 2 plus or minus the square root of 4 plus 8 over 4, which is 2 plus or minus the square root of 12 over 4, which the square root of 12 simplifies to 2 square root of 3. And then finally we cancel out a 2. So we end up with 1 plus or minus the square root of 3 over 2. Now, just as we did in the previous section, when we ended up with a plus or minus, we still took the arc sine of the plus or minus, but we ended up with 2 equations. So what we've got here is the sine of x is equal to 1 plus or minus the square root of 3 over 2. So we'll take the arc sine to both sides, and we'll get x is equal to the arc sine of 1 plus the square root of 3 over 2. And then over here we'll get x equals the arc sine of 1 minus the square root of 3 over 2. We'll go to our calculator. And in order to avoid some issues with our entry into the calculator, we could convert this to a decimal. So we could say 1 plus the square root of 3. Let's type that in again. 1 plus the square root of 3 and divide that by 2. And we can see that we're actually looking at the arc sine of 1.366025. And then over here we could say the exact same thing, but do 1 minus the square root of 3 and divide that by 2. So really we're looking at x is equal to the arc sine of negative 0.3660254. Or you could just take the arc sine of the entire thing if you're sure you're not going to enter into the calculator wrong. So the first one that we have is we're going to do the arc sine, and it's of 1.366, but I'm going to plug in the exact value. 1 plus the square root of 3, and that's going to be divided by 2, all inside the parentheses. I want to put the parentheses around the entire numerator so that that's grouped together. And I can see there that I get a domain error. So this part right here, we're going to get no solutions from this equation. And that should make sense because if I look at this arc sine, that number is larger than 1. And that what we talked about in the previous chapter, was that the domain for arcsine is from -1 to +1. So the fact that that's larger than a +1 makes sense. I'm going to get a domain error. Now this one right here I can see is -0.366. So I should get a solution from that, since that is between -1 to 1. So we're going to do the exact same thing. We'll bring up the sine inverse. And instead of plus, we're going to make that a minus. And I can see right there I've got a -21 degrees. So if I draw my reference triangle, I want to know what two quadrants is sine going to be positive or negative in. And we know it's going to be in the third and the fourth quadrant, because sine is positive in the first and the second. And right down here we get this -21 degrees. So 21.47 degrees. Over here is also going to be 21.47. Now since this number, this -21, is not between 0 to 360, I've got to add 360 to it. So you can see right there that I'm going to end up with 338.53 when I round. So x is equal to 338.53 degrees. That's going to be one solution. And I'll just write right here, -21.47. And then we have to add 360. And then this other one down here is x is 180 plus the 21.47 degrees. So 180 plus 21.47. And I can see that I get 201.47 degrees as my second solution. I could then plug this into the equation. Excuse me, not into the equation. I could then plug these answers into the equation to see if I get 0 to check. Or if I want to check it graphically, I could put 2 sine squared of x minus 2 sine of x minus 1 in y1, and then put 0 in y2, and then find the intersection.